Today's video is going to cover lesson 2.1. This is the relations part of the cluster, and we're going to go over converting between the different modes. Before we begin today's lesson, I kind of want to go over the interactive notebook and how to set it up the way that it needs to be set up. So if you can look at this example right here, you've got your notebook opened, and on the right side you can see that there's this input, and on the left side there is the output. And so on the right side of your notes you will have all of the video notes, so everything that I cover in the video, all of the terms that we define, the steps that we write down and identify, and then the examples that you see in the video will go on the right side of your notebook, including the title and the goal for the lesson. So the right side of your notebook is always going to be an even number page, and the left side of your notebook is always going to be an odd number page, and the left side is the output. So the right side is all the information that you're given, and then the left side is your opportunity to prove that you understand or you know the information that was given to you. And mainly this is going to be your problem set examples, and then if there's any questions that you have as you're going over the examples or watching the video, you'll include this somewhere on the left side, and then any notes to yourself about the lesson will go on the left side as well. Now the key to both sides of your notebook is to stay organized. So you will be graded on how organized you keep this information, and it's pretty much up to you how you organize it, and I'll give you some handouts every once in a while to paste in and to glue, and there'll be pop-ups, and there'll be creative things that we do to stay organized, but essentially it's up to you. So however you want to organize the information you see in the video, whether you want to just go straight down with it, you want to go half the side is your goal, your terms, and then the other half is the skills and concepts, then that is totally okay. With the problem set, what I definitely do not want to see is you just using this left side as some sort of scratch work. So you're just going over problem set examples, and they look like, okay, question 1 was up here, then I went over here and I was going over question 2, and then question 3 was in the middle, and then I did question 4, then I came back down here and finished it, and then question 5 was right here. What we want to see with the output is we want to see things that are clearly labeled and defined. So a great example would be, let's say you're going over your output, your problem set, and you finish up question 1. So let's say you did question 1. Label it, finish up your work, blah, 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 stayed really organized, and then box it up. Then you moved on to question 2. You went over your work, then you had a question right here, and you made some sort of column over here where you wrote your questions or your hints, or maybe you wrote them on the left side, and then we know that's question 2. Okay, then they did question 3 right here. It was a little bit longer, so you used more of the page. So however you want to do it, you may, as long as it's organized. And you'll find out very fast that the more organized you are, the less you make silly mistakes like forgetting a negative. So let's go ahead and get in the examples today. Very short video. Our goal is to be able to convert between the 4 main forms of representation. So we're going to convert, why does this keep coming up? We're going to convert from graphs, we're going to convert from tables, coordinates, and maps. You'll notice that I'm using different colors, and I encourage you to be creative with your notebook and using different colors and the way you write and how you represent things. So we're going to try to convert between these 4 forms. But before we do that, we're going to define a couple important things to know. So the first thing is inputs, or input, is represented by X. So all the input values are the X values. These are 2 different ways of talking about the same thing. And the domain, this is a new word maybe to most of us, the domain is the set or the list of all of the input values. So all of your X values in a set are considered to be the domain. So X is domain, and now your output is your Y. So output is represented by Y, and the range is the set or the list of all of your output values. So all of your Y values are considered or make up your range. So X is domain and Y is range, and these are going to be two very, very important words as you go further into math, and you'll see that in the next couple of lessons. So pause the video if you need to copy some of this down. Let's go over what the different forms look like. So we're going to use the same information to represent it 4 different ways. So let's say here we've got X is 1, we've got Y is 2, we've got X is 2, Y is, you know what, never mind. Let's say X is 1, and when X is 1, Y is 9, and when X is 2, Y is 8, and when X is 3, Y is 7, and when X is 4, Y is 6. So this is a table here, and you'll see the X values on the left, the Y values on the right. Well, if you took the table of values and you made a map, or you mapped them, well actually if you took the table of values and you created coordinate points, what would happen is when X is 1, Y is 9. So when your X is 1, your Y is 9. That is the coordinate point there. When Y is 8, X is 2. So when X is 2, Y is 8. So 2 and 8 are a coordinate point. Likewise with 3 and 7 and 4 and 6. So this is what the information looks like in a table. This is what the same information will look like in coordinates. Now domain and range, this is called mapping. So when X is 1, and we've got X is 2, we've got X is 3, whoops. And we've got X is 4, so we're going to map these different numbers, and I'll use a neutral color. So we got 6, 7, 8, and 9. So when X is 1, the corresponding Y value, or its range counterpart, is 9. So we're going to map 1 to 9. When X is 2, the Y value, or its range counterpart, is 8. So we're going to map 2 to 8. The corresponding Y value for when X is 3 is 7, so we're going to map 3 to 7. And then the corresponding X value for 4, or Y value for 4, is 6, so we're going to map 4 to 6. So that's what this information will look like if it was mapped. You map your domains to the corresponding range or Y value. And then the last little bit is graphing. So you just take your coordinates from either the table, the map, or the list of coordinate points, and you plot them on a graph. So we've got 1, 9, so when X is 1, Y is 9, that would be this coordinate point up here. When X is 2, Y is 8, 2 here, 8 here, so on and so forth. And we got 3, 7, and we've got 4, 6. And you can see when X is 4, Y is 6. So that's what it looks like on a coordinate plane. Let's go over an example today. So here we have a map, and they've mapped all of the X values to Y values. We've got our domain, and we've got our range. We've got domain. Why does it always forget to hit the button? We've got domain, which equals our X, which is our input. And we've got range, which equals our Y, which equals our output. So when the input is -1, the output is 6. So if we have this coordinate point, we're missing the X here. Remember, X, Y, X comes before Y in the alphabet. When Y is 8, what is X? So are we going to look for domain or range? Well, range is Y, so when Y is 8, it looks like X is 3. Now this one has 2 blanks, so we're going to come back to it and save it for last. this is the x value here. When x is 5, what is y? Y is 2. That's the corresponding value for x. And then our last coordinate point, we've got 3, 8. We've got 5, 2. Now we need -1 for x and 2 for y. So that's how you would go over a problem like this. And now for the last example for today. Here we have a graph that's given to us, and we're being asked to fill in the coordinates. So let's go ahead and start with the first coordinate. The missing value here is x. Well, we've got the y value. Y is 0. Y is 0. So if we're looking at this coordinate plane, we know that 0 is in the middle. We know that this is y. This is our output. And we know that this line here is our input. So when our output is 0, what is our input? So we go 0 on output. Any points? Okay, the coordinate point is right here. What's the x value right there? It's -6. So we're going to put in -6. Now we're given the input, -10. So we're going to go to our input line. And we're going to -10, which is right here. Where's the point? The point's right here. It's L. What's the y value there? Looks like the y value is 4. So we're going to type in 4. This one's got a double blank, so it'll be the last coordinate. We'll come back to it. We've got a input of 7, so we're going to go to our x, 6, and then 7 would be this line right here, and then it looks like our output is m, which the y value there is in between -6 and -8, which would be -7. And then our output is 6. So when our output is 6, we're going to go right here, and it looks like it's k. What's the input, or what's the x value? Looks like it's between 2 and 4. It's going to be 3. And then our last coordinate point, well, we've got all of them except n. So what is our x value for n? In between 4 and 6, that's 5. And then -6 for y. If you have any questions on the problem set, please email or message one of your classmates or me through Schoology, and we'll try to help you out. Make sure you have your input page labeled number 2 and your output page and your problem set examples page number 1. Good luck.